One day, thick smoke and fire is observed coming from a hydraulic power unit on board the Tordenskjold installation. The fire alarm goes off and personnel on board start extinguishing the fire. After a few minutes, the fire is out. In this presentation, you are going to see what caused the fire and what we can do to avoid this kind of incident in the future. To understand the cause of the fire, we need to understand the system and the story behind. The power unit consists of a closed container with a tank, hydraulic pumps, and a diesel motor. The power unit generates hydraulic power. One day, there is a leakage in the hydraulic power unit, which results in a pipe being replaced. The hydraulic piping was originally steel, but because of the leakage, this steel pipe is now replaced by a hydraulic hose. The investigation report after the accident asserts that the hose does not meet the specifications for the load pressure. In addition, the hose is installed in such a way that it is subject to wear and tear. The hose is installed right beside a sharp edge. The way the hose moves around leads to repeated abrasion against the edge. 9 months later, the hose ruptures. The power unit is now a firebomb. The ruptured hose causes high-pressure hydraulic oil to gush out. The direct cause of the fire is that the hydraulic oil comes in contact with the motor's exhaust manifold. The combination of the high pressure and the heat from the manifold instantly causes a fire. The fire is quickly extinguished. There are minor damages, but it could have been a lot worse. Shortly before the fire, the power unit's diesel tank is filled up. According to procedure, one person must supervise refueling due to the risk of discharge in the event of overflow. If fire breaks out during refueling, the incident can result in serious personal injury. In the worst case, death. This incident is an example of how even small modifications require risk assessments. There are many similar modifications on our onshore installations and platforms. There are many elements of risk that must be considered when replacing piping with a hose. Now it is up to you to consider what you deem necessary. Click and drag the respective elements of risk into the list. Here you can see which elements of risk we must consider in conjunction with changing piping to a hose. The idea of replacing the steel pipe with a hose is good, but the assessment of the installation and the risk for wear and tear is not good enough. Neither is the hose assessed properly in relation to the pressure. Better quality assurance of the job can reveal unfavourable conditions. The following participants should be involved in this work: An immediate supervisor or a colleague should be involved to control the work. In this instance, the manufacturer can provide assistance through specifications and drawings of the construction if you don't already have them. There are many factors we must consider for similar modifications. The design must be approved. The manufacturer must verify the modification. You must conduct a risk assessment in order to reveal potential elements of risk, taking into consideration pressure, temperature, installation, fatigue, wear and tear, and vibration. Always have another qualified person evaluate the quality of the modification. Consider the procedures you have in place for modification work. Do these procedures apply to all modifications, or are there exceptions for small and simple modifications? How do you ensure that these kinds of incidents don't happen in your workplace? Our work is never so important or so urgent that we don't have time to work safely.